Sometimes linear systems have one solution. Sometimes they don't necessarily have one solution. We're going to investigate how many solutions a linear system may have. If you have access to graph paper, so we have system number 1 is going to be y equals 3x plus 5, 2x plus y plus 10 equals 0. System 2 is going to be y equals 2x minus 3, and then 2x minus y plus 1 equals 0. If you're not familiar with this format, you could either, this is the standard form, you could either graph it by quick graphing or by finding the intercepts. And the third one is going to be y equals 2/3 x plus 1, 4x minus 6y plus 6 equals 0. So at this point, you could pause the video and graph these three things. I'm, of course, not going to pause, so I'm going to continue. So first we're going to graph the very first one. So it's going to be number 1, which is y equals 3x plus 5, 2x plus y plus 10 equals 0. So 3x plus 5, we start over there. We go over 1 up 3, and then backtrack slightly. And we get this line over here. Roughly. And then this one over here, you could either move things over, so you could either graph y equals minus 2x plus 10, or you could find the intercepts. I'm going to do it with the intercepts. So to find the x-intercept, I make y 0, so x is negative 5. To find the y-intercept, I make x 0, so y is negative 10. And there we go. And they meet over here, so it looks like there is a not very exciting one solution. And the solution in this case is minus 3 minus 4. Okay. Let's look at the second one. So the second set that I was doing was y equals 2x minus 3, 2x minus y plus 1 equals 0. So y equals 2x minus 3. I start off at minus 3. And I go up like that. And I make my line. And this is the line y equals 2x minus 3. So there we go. Now I'm going to graph this one over here. So if I'm going to rearrange that, that would become 2x plus 1 equals y, or y equals 2x plus 1. So I start at 1, and I go up like this. And then I draw the line. So what we notice, that was y equals 2x minus 3. This is essentially y equals 2x plus 1. And these two lines are parallel. So when are they going to meet? The answer is that they are never going to meet. So since they're never going to meet, there's no point that is on both lines, which means there's no solution to the linear system. So there's no solution that works for one that works for the other. that also works for the other. So there's no solution to the linear system. Right? So sometimes we have one solution. So here we had one solution, but here we have no solutions. Okay. And then the last one we have is, looking back to there. So our third one is y equals 2/3 x plus 1, 4x minus 6y plus 6 equals 0. So y equals 2/3 x plus 1. That one's fairly straightforward. I'm going to do this one, and I'm going to do the top one in orange, actually, because... So we start at 1, then we rise 2, run 3, rise 2, run 3, rise 2, run 3. And then we draw our line using our trusty ruler. Now this one over here, I'm going to find the intercepts. So you could rearrange it and try to graph it, but if we rearrange it, if we find intercepts, so the x-intercept is going to be minus 6y is minus 6. So to find the, so for this one over here, I'll do it in green actually. This one's going to be done in green. So to find the y-intercept, we know that minus 6y equals negative 6. So y equals 1. So that's the y-intercept. And then the x-intercept, we have to make the y equal to 0. So we're going to get 4x equals negative 6. X is minus 1.5, which is going to be around there. And what we actually notice is that it's the same line. I'm going to, now technically I should be drawing it right on top. I'm going to try to draw it a little bit below, but let's imagine that it's right on top of the yellow. So I'll do it right on top actually anyway. So what we see is that this line and this line are actually the exact same line. Now where do they meet? They meet here and here and here and here and here and here. In fact, they meet everywhere along the lines. So there's an infinite number of solutions. So what we say in this case is that there are infinitely many solutions. It doesn't mean that everything is a solution. It just means that there are infinitely many solutions. So to recap, we can have one solution, or no solutions, or infinitely many solutions.